So now we move on to our next topic. We've worked with rational functions before. So 1 over x, 1 over x squared, 1 over x cubed, and so on. Well, we know that if you have something of the form 1 plus x over x squared, I'm just making this up, you can separate that into 1 over x squared plus x over x squared, which is equal to 1 over x squared plus 1 over x. But we know that if you have the opposite, so if you have x squared over 1 plus x, this is not equal to x squared over 1 plus x squared over x. You can't separate the denominator of a fraction. So if you can't separate the denominator of a fraction, if you have something complicated, what do? So, for example, if you have, say, 1 over x times x plus 1, what do you do there? Well, as it turns out, a good guess would be to say that this was, say, 1 over x plus 1 over x plus 1. But it's not quite right, because if you add these back together, you get, let's see, what is this? This is x plus 1 over x times x plus 1 plus x over x times x plus 1. And add those together, and you get 2x plus 1 over x times x plus 1. But you'll note that 2x plus 1 is not the same thing as 1, because we have this extra 2x piece here. So where did that 2x come from? Well, that 2x came from taking this x and adding this x. Is there any way that we could get rid of those x's? Well, we know that this x is positive. It's already there. But what if we made this x a negative, so we were subtracting it? Then when you added these two things together, they'd cancel out, and you'd get rid of this, and then you just have 1 equals 1, which is exactly what we're looking for. So how can we make this a negative? Well, we could change the denominator, but then if we change the denominator, we have to change this one, and if we change that one, we have to change this, and then we end up with a minus 1, which again isn't equal to 1. Or we can make it a lot easier. Leave these two the same and just make the numerator over here minus. So let's test it out. 1 over x minus 1 over x plus 1. And as you can see, x plus 1 minus x over x times x plus 1. The x's cancel, and we actually get what we were looking for. Well, this is the process. This is the process for simplifying rational functions that have multiple factors in the denominator. This is the only way you can simplify a fraction or separate a fraction using the denominator. Using the numerator, if it's a polynomial, so it has multiple terms, then you can separate it. But in the denominator, the only way that you can separate it is if it has these multiple factors. Now, you'll notice that the way I figured out what these two terms were was kind of by inspection. It was just looking at it without actually doing any sort of real process. What I'd like to show you now is how to do this exact same problem, only using a more formal approach that can be applied to other problems. So let's start this over. So you have 1 over, let's write it like this, x squared plus x. Now, your first step, so step 1, is factor the denominator. So you're going to have 1 over x times x plus 1. Step 2, right, this is step 2, is going to be rewrite the denominator. Now, what do I mean by rewrite the denominator? I mean separate it out. So you want to write two fractions here, and you want to have a plus sign between them, and you want the two denominators to be the factors of the denominator over here. So you have something over x and something over x plus 1. Well, this is math, and this is math that knows algebra. So what do we do when we say a number that we don't know? We use a variable. So let's use capital A and capital B. So what we're saying is 1 over x times x plus 1 is equal to some number divided by x plus some number divided by b. So Step 3. Clear the fractions. How do you clear the fractions? You multiply by the least common multiple of all three fractions. So you have 1 over x times x plus 1, x, and x plus 1. Well, since these two came from this one, you could just multiply both sides by x times x plus 1. And so what you get now is you get 1 is equal to a times x plus 1 plus b times x. So now let's multiply this out. So you get 1 is equal to ax plus a plus bx. Rewriting this again, we get 1 is equal to a plus b quantity times x plus a. Now here's an issue because we have one equation but we have two unknowns. But Ben, don't we have three unknowns? No, because we don't really care what the x is. The x just stands for any sort of number that we'd plug into our original function up here, or original expression. So we're just looking for a and b, but we only have one equation. So what do? Well, there's this lovely trick called equating coefficients. This side over here, you know, is equal to 0 times x plus 1. So you have a polynomial on the left and you have a polynomial on the right. What you can say is anything times x on the left is going to equal anything times x on the right. Follow me? So, for example, like this one here, this one can't contribute to this a plus b. It's just you can just set the coefficients equal to each other. So set the coefficients for the x equal to each other. You get a plus b on one side is equal to 0 on the other. And then for the units, you have a is equal to 1. So this is a fairly simple system of equations. So if you know a is equal to 1, then you can substitute it in here. So you get that, you get that 1 plus b is equal to 0. Solve for b, and you get that b is equal to negative 1. So what are we really doing here? This is just a systematic way of figuring out what a and b should be by actually combining the fractions and then figuring out what we need to compensate so that the right-hand side over here equals the left-hand side over here. So this tells us that a is equal to 1, b is equal to negative 1. So this should be 1 over x minus 1 over x plus 1, which is exactly what we found before. So in our next video, we'll talk about how to set these up for things that are a little bit more complicated.